Hi guys, today I want to discuss some identities of differentiation. Earlier I explained some rules of differentiation and some basic question in the first video. I explained the things, but today I want to discuss some differentiation identities. So there are some differentiation identities you can see on the board, okay? And this identity, if you see the first one, so you can see this identity I have explained earlier, okay? This is what x to the power n. X to the power n is equals to n x to the power n minus 1. Means power, there is power n, so power will multiply and power reduced by 1. That is identity. I have explained this one earlier. And exponential function will be the same. So exponential function also I have explained in the last video. And exponential function means e to the power x, differentiation of e to the power x will be same, e to the power x. And the ln function, if there is any ln function of x, suppose that, then the differentiation of ln x will be 1 over x. And there are some identities for differentiation, like trigonometric functions, and some for ignorant trigonometric functions. So you can see here trigonometric functions. So the differentiation of sin x. So what will the differentiation of sin x? It will be cos x, and the differentiation of cos will be minus negative of sin, and the differentiation of tan will be sec square x, and the differentiation of sec will be sec into tan. Okay, got it? So after this, the differentiation of cot will be negative of cosec square x, and the differentiation of cosec function will be negative of cosec into cot. And there is one the different identity is like if there is a is constant value, if the constant value and x is variable. So if there is any constant value and the power is variable, and if we want to do the differentiation of this one, so the differentiation of this function will be a to the power x into ln of a. ln of a means a is constant. So like suppose a is what? Like suppose a is 2. Okay, I will explain one question over there. Suppose that 2 to the power x. If you want to differentiate 2 to the power x, so how can you differentiate 2 to the power x? It will be 2 to the power x same and the ln of a. A means 2. Okay, so remember this. And after this, the 11th one is differentiation of inverse trigonometric function means sin inverse x. So differentiation of it will be 1 over root of 1 negative of x square. And the differentiation of tan inverse x will be 1 over 1 plus x square. Same as differentiation of sec inverse x is 1 over x into root x square minus 1. And in cos sin inverse, this is 1 over root 1 minus x square. And in cos, it will be negative of this one. Negative of this one. You can see here. And in here and here, you can see the difference. Only the negative sign difference. Okay. And here you can see only the negative sign difference. Okay. So I want to discuss some questions regarding these identities. So how we solve some questions. Okay. So first I will discuss some questions. So first question is, if there is any function, like suppose that root of x tan x. So how can we solve this one? Differentiate. And the question is, you have to find dy over dx. How you differentiate this function? This is a function like in the root term, so root of x tan x. So how can we solve this one? So first we will let y, if the function is y is equals to this one. Okay. So in the root function, so there are a root and this function. This is combined function x into tan x. Okay. So x tan x means suppose that this is t. So if x tan x is t function, and then y will be what? Y will be root of this. The root of this. This is what? T. So root of t. Okay, and the differentiation of root function, with the help of this one we can solve differentiation of root 1. So differentiation of root, if there are any function dy over dx and it is root x, suppose that, so how can we solve this one? The root means the power is half, so you have to solve this one. Okay, so I have discussed this identity in the last videos also, and the power is what? 1 over 2, and the power will reduce by 1, so it will be x to the power 1 over 2 minus 1. 1 over 2 minus 1, so it will be 1 over 2 x to the power minus 1 over 2, and we can say 1 over 2 root x. Directly we can say 1 over 2 root x. Okay, so differentiation of root x will be what? 1 over 2 root x. So here I am using direct form, so dy over dx. So dy over dx will be what? 1 over 2 root t. I explained this one, how the differentiation of root x is 1 over 2 root x. All the steps, first, second, third and fourth. In the fourth step we get answer this one. So I am using directly over here. So the equation, maybe it is first equation. Okay, so differentiation of this one t, and this one in the previous video you can see the product rule. Okay, first rule was product, second was divide rule, and third was chain rule. So you can see in the previous video the differentiation of this one dt over dx will be suppose that this is first function, this is second function. Okay, so first function is what, x, and the second one is 10x. So differentiation of 10 is what, sec square x. I am using directly, I am not using solving each and every step. Okay, so second one will be constant, and the differentiation of x is 1. Okay, so dt over dx will be x sec square x plus 10x. Got it? This is dt over dx. This is dt over dx. So we can select equation number 2. Here it is 1 and there it is 2. So if we find the product of both equations, so dy over dx and dt over this one. So dy over dx, product of dt over dx, dy over dt, it should be dy over dt. Okay, so because variable is t, so this will be dy over dt, dy over dt into dt over dx. So if you want to find the product, so it will be 2 root t, and product of with this one, it is x sec square x plus 10x. I hope it is clear. Okay, so t you can cancel out here, so it will be dy over dt, dy over t will be cancelled out, so it will be dy over dx. Okay, dy over dx remaining part, and t you can substitute the value of t from here, so it will be x sec square x plus 10x. Okay, over 2 root t, t is this one, so 2 root t is this one, x 10x. That will be the answer of our question. Okay, hope this question is clear. Okay, so let's move to the next question. The question is what, y is equal to sine in the bracket, it is 2 cos 3x, and you have to find the differentiation of this one. Okay, so what we do, this function is what, sine, and the function is what, cos. There are two functions. Okay, so the bracket function, we suppose that this is suppose that t, so t will be what, 2 cos 3x. Okay, and the y function will become now y is equals to sine t. Okay, sine t. So we have to first differentiation of this one and then differentiation of this one. So when we solve this one, when we find the differentiation of this one, so it will become dy over dt is equals to differentiation of sine is what, cos, so it will be cos t. Okay, so the equation number 1. Okay, and if we want to find the differentiation over here, so it will be dt over dx. So dt over dx will be what, am I solving this directly. Okay, in the previous video I have explained the differentiation of cos 3x and sin 3x. Okay, this was getting solved by chain rule. Okay, I am solving this directly. So 2 is constant, so 2 will be constant, and the differentiation of cos x. Okay, remember this, differentiation of cos x, differentiation of cos will be negative of sine. Here you can see differentiation of cos is negative of sine. Okay, so it will be negative of sine, and the angle is what, 3x. So 3x will be same. Okay, and now we will do the differentiation of this one. Okay, this one will also differentiate. So 3x, the differentiation of 3x will be 3. Got it? So 3 multiplied by 2, so it will be negative of 6, and there are negatives, so negative of 6 sine 3x. So it is what, dt over dx. The equation number may be 2. Okay, so when we find the product of both equations, so product will be dy over dt and dt over dx. So here it is cos t, and here it is negative of sine 3x. And dt you can cancel out, so it will become dy over dx, which we have to find. Like dy over dx, we have to find. So dy over dx is what, cos t, and negative of this one. So we can put this one in the front. So it will be negative of sine 3x and cos t. T is what? T is here, this one. So t will be 2 cos 3x. Okay, so now that will be the answer. Okay, let's move to the next question. The third one here, y is equal e to the power 2x plus ln of x square plus 1. So here you can see there are two functions. Okay, note in the multiplication, note in the divide. So how do we solve this one? So we have to differentiate these functions with respect to x. So what we do in this? So differentiation of this one with respect to x, it will be dy over dx. Okay, you know this. So differentiation of this one, so differentiation of e to the power 2x. here the differentiation of ln of x square plus 1. We have to do this one, okay? So how can we solve this one? First we solve this one and then we solve this one, okay? So the differentiation of e to the power 2x. So differentiation of e to the power 2x will be what? The differentiation, I have explained this one here, exponential function will be same, but here power is 2. In the previous video, you can see the difference. If the power is different, so how can we solve? With the help of chain rule, I explained one question of that one. Okay, so e to the power 2x, I am explaining this one directly. So e to the power 2x, the differentiation will be same, and we have to differentiate what? We have to differentiate this one, power. So 2x, okay? So differentiation will be what? Differentiation of 2x will be 2, okay? So because the differentiation of x is 1 and this is constant, we cannot differentiate constant now because constant will come in the front, so it will be 2 and e to the power x and differentiation of x will be 1, so e to the power 2x. So let's suppose this is equation number 1, okay? And so here it is what? d over dx means differentiation, we have to do this one. So d over dx of ln of x square plus 1 function, okay? So differentiation of this one, you know this, the differentiation of this ln function of x is 1 over x. So differentiation of this one will be what? 1 over x square plus 1, okay? And now what we do? We do the differentiation of this one also. So differentiation of x square plus 1, we have to do this one. Okay, so differentiation of x square plus 1, it is like an easy function. With the help of this formula, we can solve this one. X to the power 2, so the differentiation of this one will be what? 2x. And differentiation of 1 is 0. Because here there is no variable, only the constant. And if there is only the constant, then the differentiation of this one will be 0. Okay, so 2x, okay, 2x over x square plus 1. So this is what? Let's suppose equation number 2. So we have to find the dy over dx. So dy over dx will be what? dy over dx equation 1 and plus. Now we have to add the equations. Equation 1 plus 2. Okay. You can see the difference in the last previous question and here in this question. Okay. So dy over dx will be what? Now this one is equation number 1. So it will be what? 2e to the power 2x plus, and here 2x over x square plus 1. Here you can see here 2. So you can take 2 as a common. So it will be like e to the power 2x plus x over x square plus 1. That will be the answer. Complete answer of this question. Okay, so we'll shoot the next video of maybe differentiation, some HOT questions, or maybe some different topic we will discuss in the next video. Thank you so much. Bye bye.